Assalamu alaikum and good day. So now we'll be continuing our discussion on capital structure and leverage by taking up a sample on how to determine the optimal capital structure. Okay, so just for a recap, our optimal capital structure is the level of structure, is the capital mix that would give us the highest stock price and the lowest weighted average cost of capital. So since there's a subjectivity part on the stock price, we tend to focus our analysis on the capital mix that would give us the lowest WACC or WACC. Okay, so here we have a sample problem for big B. This slide shows the interest rates for big B with different debt assets ratio. So if we will borrow 20,000 with a total capital of 200,000, then our debt asset ratio would be 10%. And that would be from 20 divided by 200. So that's 10%. Our interest rate, if we will borrow 20,000, is 8%. Okay? So, this 8% will be subjected to the after-tax rate later. Okay? So, the same with if we borrow 80,000, then 80 divided by 200, and that would give us 40%. And the cost of borrowing 80,000 is 10% interest rate. So, the same with 120,000 borrowing. So, that would be 120 divided by 200. So, we have debt asset ratio of 60%, and the cost of borrowing 120,000 is 15% interest rate. Okay, so we have here the stock price and the WACC, the WACC estimates with different debt assets ratio. So again, I repeat, everything here is computed. Okay, so we have the assumption that Big B pays all of its earnings out as dividends. So our EPS is equal to our DPS, and then our firm's unlevered beta is 1.5. Okay, so unlevered beta, if there is no debt, the Big B company will not put debt into their capital mix, then its beta is 1.5. Then we have here an assumption for the risk-free rate, 6%. So again, risk-free rate, mostly the basis of this are the treasury securities. And we have the risk premium, okay, we have 4%. Okay, so these are the assumptions. So again, everything here is to be computed. So for example, our first computation would start with our beta. Okay, so we have the Hamada equation later, so I will just show it. So this is the Hamada equation, and the Hamada equation is again very important in determining the optimal capital structure. According to Hamada equation, the levered beta is equal to unlevered beta multiplied by 1 plus after-tax rate multiplied by the debt-equity ratio. Please take note that this is not the debt-asset ratio, but the debt-to-equity ratio. Okay? So, for every time, every capital mix will be computing the beta, the levered beta. So of course, if Big B company has no debt, then our beta there is the unlevered one, the 1.5 given in the problem. But as we add debt, if we put debt, we borrow, then we will be computing for the levered beta. Okay, so again, the first step would be to compute for the beta. So given here that our unlevered beta is 1.5, using the Hamada equation, levered beta is equal to unlevered beta multiplied by 1 plus after-tax rate times the debt-equity ratio. Okay, so we have here our debt-asset ratio. So Debt asset ratio is the debt divided by the total assets or total capital, total liabilities and capital. So if we have a debt asset of 0%, our debt equity would be 0. Why? Because we have no debt. 0 divided by 200 is equal to 0. Our unlevered beta is 1.5. When we compute for the levered beta, okay, here this column here is the levered beta. So that would be unlevered beta multiplied by 1 plus 1 minus tax rate times the debt equity ratio. Since our debt equity ratio here is 0, then automatically the answer here in this part for 0% debt would be 0. So 1 plus 0. So unlevered beta multiplied by 1, that would give us 1.5. So this is the factor given from the Hamada equation, and this is pala, the levered beta. So we just do that for the other levels. For example, that asset ratio of 10%, meaning we have 10% of the total asset. So if our total asset is 200, we have 20 over 200. Okay, so meaning the equity there would be 180, right? So 20 divided by 180. So that would give us 11.11%. Okay, so if just plug this in the Hamada equation, so we have 11.11% multiplied by the after-tax rate of 60%. Okay, so we get the factor 1.07 here. So this is the factor 1.07. So actually it's 1.06666, etc. Okay, so multiply that by 1.5, our unlevered beta, we will get the levered beta of 1.6. So just do the same. If example we have 20% debt asset ratio, that means 20% of our assets is coming 20% of our assets is being financed by debt. So we have 20% out of 200, we have 40. So 40. So ibig sabihin, we have 160 from equity. Okay, so our debt equity would be 40 over 160. Okay, so 40 over 160 or 25%. So just again, plug that in here, the 25% in the debt equity ratio multiplied with after tax rate plus 1. So we have here the factor of 1.15. Okay, so this is the factor of 1.15 multiplied by the unlevered beta here, 1.5. We get 1.73 levered beta. Okay, so on and so forth. So where will we use this? So we will use this beta here in this part in computing our cost of equity using the CAPM method. Okay, so let's try again to compute. So again, we have their assumptions. Our earnings are paid out as dividends, everything, no? So our earnings per share would equal to our dividends per share. Our unlevered beta is 1.5, and we have the assumption for the CAPM equation. So we have computed already a while ago the computation for the levered beta. Okay, so we will use this beta here in this last column to get the cost of our equity. So again, step 1, compute the beta, estimate the beta. Okay, so we have already estimated that the beta of 0% is 1.5, and that is given in the problem. We just computed it using the Hamada equation, right? But it is also given in the problem that without debt, our unlevered beta is 1.5. Okay, so we will start there. So at 0 debt assets, our debt equity is 0, as I have mentioned a while ago. Then we have the after-tax cost of the debt. So this is the 60%, okay, of the interest cost. Okay, so we have given 8% times 60% after tax. So next we will compute the expected earnings per share, and that would be equal to our dividends per share. So a while ago we have computed that our EBIT would be 40,000. Okay, our EBIT would be 40,000. So there's no interest. So the only factor for our EBIT is the tax. Okay, so we have an after-tax net income of 24,000. Okay, so we just divide that by 10,000 shares outstanding. Okay, so we have 2.4. Okay, so now we have the beta that we have computed but also given for unlevered 0% debt 1.5. Then we compute the cost of equity using CAPM. The risk-free rate 6% plus the risk premium multiplied by the beta. So risk premium of 4% multiplied by 1.5. Okay, so we have 4 times 1.5, so we have 6 plus 6%. So our cost of equity will be 12%. Okay, so since our earnings per share is equal to our dividends per share, we can compute for our estimated stock price. Okay, using the zero growth stock model. Okay, so that would be dividends per share divided by cost of common stock. Okay, so we have our dividends per share of 2.4 divided by cost of equity of 12%. So we have our estimated stock price of 20 per share. Then we get the price earnings ratio. Price earnings ratio is equivalent to the estimated stock price divided by the earnings per share. So we have our stock price of 20 per share divided by earnings per share of 2.4. So we have price earnings ratio of 8.33 times. Again, this is times. This is not percent but times. Okay? So it means that our stock is priced 8.33 times more than its capability to earn. Diba? That's what is meant by price earnings ratio. So we can compute here the WACC. Okay, and this is the main basis, no? And also the stock price. So actually, later you can see that the what maximizes the stock price, what level maximizes stock price is also the level that minimizes our WACC. And that would be our optimal capital structure. So here, let's start with 0%. So we have WACC. We will compute the debt and the equity. So our debt is 4.8%. Okay? But its composition, the weight of debt is 0. So therefore, our debt is 0. So we have the equity natin. Equity is 12%. And that is 100%. So we have our WACC of 12%. Okay, so again, we just continue with our problem. So if we have debt asset of 10%, so it means we have borrowed 20,000. And that 20,000 will be used to repurchase the stocks outstanding. So therefore, our shares outstanding would be reduced by treasury shares. Okay, so that is the assumption of borrowing, no? So we borrowed because we wanted to restructure our capital mix. So that's why we borrow so that we can buy back some equity, and that would compose our total capital. So if we borrowed 20,000, then meaning the equity portion that finances our assets is 180,000. So 20,000 divided by 180,000, we have 11.11%. Okay? So this is the debt equity ratio, and that was used when we computed our levered beta. And we have here our levered beta of 1.6. So again, we computed already the beta of 1.6. So now we can compute for our cost of equity first. Okay, so let's compute first the cost of equity. So we have 1.6 multiplied by the risk premium plus 6%. So that would give us 12.4% cost of equity. Okay, so for the debt, the interest rate of 20,000 borrowing is 8%. So the after-tax rate would be 4.8%. So this will be used in our WACC. Okay, so our expected earnings per share, so our earnings, our EBIT is constant at 40,000. So 40,000 less the interest expense, because yan lang yung nabago na variable, the interest expense. So 40,000 minus the interest expense of the 20,000 borrowed, 20,000 times 8% interest. So we have 1,600. So that would be deducted from our 40,000 EBIT, and we divide that with the shares outstanding of 9,000. So why 9,000? Because we used the 20,000 to buy back 1,000 shares. Again, we are restructuring our capital mix. So the assumption here is we borrow to buy back existing equity. So we will be reducing from time to time. As we borrow more, we will be reducing our shares outstanding. Okay, so shares outstanding natin would be 9,000 only. So that would give us earnings per share of 2.56. So that will also be with the same with our dividend per share. Okay, so we have computed this one, this one. So we have the stock price. So our stock price would be the dividend per share of 2.56 divided by the cost of equity of 12.4%, and that would give us a stock price based on the zero growth stock model, 20.65. Okay, so again, we have the price earnings ratio, price 20.65 divided by 2.56, so that will give us 8.06 times. Again, times, price earnings ratio is times. Then we have the WACC. So now we can compute the WACC. So our WACC now is composed of 10% debt. Okay, so that is the weight, 10% times 4.8 after tax cost of the debt plus 90% of multiplied by 12.4%. Okay, so again, this 12.4% is weight multiplied by its weight of 90%, and this 4.8 after tax cost of debt will be multiplied by 10%. Okay, and that will give us a WACC of 11.64%. So you will just again do this procedure, the same procedure on the other mix, capital mix. Okay, so for self-check activity, please do the WACC for this whole data, the WACC, the price earnings ratio, the estimated stock price for debt level 20% and 30%. So now I will proceed to discuss 40% debt capital. Okay, so if we have debt asset ratio of 40%, so this means that our debt is 40% of the total 200,000. So therefore, we have 40 over 60, right? Okay, so 40 for debt, 60 for equity. So 40% of 200,000 would be debt, and the remaining 60% of the 200,000, the 120,000 will be the equity. So we have for the debt equity, so we have 80 divided by 120, and that would give us 66.67%. Again, this debt equity was used as we compute the Hamada equation beta, no, for the levered beta. So now we can continue. So the cost of interest rate at 40% of debt, the 80,000, okay, was given in the problem. Then we have the estimated expected earnings per share. So we just again compute the earnings per share, And here, our shares outstanding would be, again, reduced because we'll buy back, again, the shares, right? Okay, no? So, again, we have the 80,000 and debt, and that will be used to buy back our shares. So, that would mean that we will buy back 4,000 shares. Okay, so 80,000 divided by 20. Okay, so that would be 4,000 shares. So our remaining shares outstanding would be 6,000 shares. Okay, so again, our after-tax cost is 6% because we have 10 times after-tax rate of 60%. So earnings per share natin, so we have EBIT of 40,000 minus the interest expense of 8,000. Where did we get 8,000? 80,000 debt borrowed multiplied by the interest cost expense of 10%. So that's 8,000. So we have 40,000 minus 8,000 multiplied by the after-tax rate. So we have EBIT after tax divided by shares outstanding of 6,000. So we have expected earnings per share of 3.20. Okay, so we have already computed our beta of 2.10. So we can compute now the cost of our equity. So 2.10 multiplied by the risk premium 4% plus 6% risk-free rate. So we have cost of equity of 14.4%. Okay, so now we can compute the estimated stock price. Stock price using zero growth stock model. So we have the dividend per share, 3.20 divided by 14.4%. So we have stock price of 22.22. So we have, again, the price earnings ratio of 26.94 times derived from 22.22 divided by 3.20. Okay, so now we can get the WACC. Our WACC would be 40% of debt. So 40% weight of the debt times after tax of 6% plus 60% times 14.4 cost of equity. And that would give us 11.04 WACC. Okay, so as you have computed in your self-check, no, I have asked for self-check number 1 for level of debt level of 20, self-check number 2 for level of debt of 30, the solution because the answers are here. So this is the WACC for 40%. So for self-check number 3, please compute for the debt the solution. Give me the solution for the everything here for level 50, and self-check number 4 would be for the level of 60. So as what we can see here, assuming that you have already shown your solution, so we have here the answer. So you can see here that the optimal capital structure is the one that maximizes our stock price, because at 40, which is apparently our optimal capital structure, our stock price hit the maximum price of 22.22. Then after this, it declined. The same with our WACC. They are at this capital structure, 40 debt, 60% equity. We have the lowest WACC ever, and that is 11.04%. After this, any addition of the debt will increase our cost of capital because there's too much risk already borne by the stockholders. So as you can see here, our cost of equity will be declining from this point onwards. Okay, so the benefit of having a cheap source of capital from debt was offset by the risk borne by the stockholder. So that's why our optimal capital structure here hit the maximum at the 40% level and also hit the minimum WACC at 11.04%. So therefore, our optimal capital structure is 40% debt, 60% equity.